Hi, in this video we are going to work on areas of sectors. As we talked about in one of the videos before, that sector is actually the section of the area of a circle which comes from the center, and it has got two radii or two radiuses inside. Okay, so sector can be a minor sector like we've got in this case, smaller part of a circle, and it can be a major sector if it's on the other side. Okay, so major sector normally carries an angle bigger than 180. Okay, so it has to be a reflex. I mean, minor sector can be an acute or obtuse angle, right? Okay, now what we are looking at is how to find the areas of sectors. I've written down the formula. Now it's important to understand the formula. Okay, now that actually is the area of a circle formula, pi times radius squared. Okay, now where did that theta over 360 comes from? Right, now if I have full area of circle, I should be writing it down as 360 over 360 because I'm considering total area of a circle. But in this case, if I need to work out just the part of a circle, part of the area, okay, in that case I need to know what proportion or what part of the circle I'm looking at. Okay, and that is the angle. Okay, so if I look at this example, I'm only looking at 70 degrees out of 360 degrees of a circle, right? That length is the radius. Okay, and that we also talked about that. That's an arc length, right? So area of sector, what I should do always I should start writing a formula down. Okay, so theta over 360, like I said, theta is the angle in the middle, okay, times pi radius squared, okay, which is again the area of a circle, right? Now theta is 70 degrees in this case, so 70 degrees out of 360 times by pi, and radius in this case is given, which is 8 squared, right? Now it's a good idea to start working out, if you follow the BIDMAS rule, we should work out this the index bit first. Okay, so 8 squared is 64, right? Now in this case I can use the calculator. So 8 squared is 64 multiplied by pi, which is 3.142 up to 3 decimal places, times it by 70, okay, which makes 14,076.16, and divide that by 360 will give me the value of area of this sector, which is 39.100. so it's 39.100, which is 39.1 centimeters or meter squared up to, okay, so in this case it's meter squared, right? So because my radius is in meters, so my area has to be in meters as well, right? What I'm looking at now in the second example, that's more like an obtuse angle. The formula must be written down first, so theta over 360 times by pi radius squared. Okay, this time I used capital R for radius. Okay, it's doesn't make difference whether it's capital or smaller r. Okay, now area would be, the angle in the middle is 160 degrees this time, over 360 times by, I'm putting down value of pi, which is 3.142, and I'm putting down 9 squared. Okay, I can put these values in a calculator. Okay, so if I put these values in a calculator, I would get 160 degrees times by 3.142 and multiply that by 8 squared, which is 81. Okay, and divide that total by 360 degrees, and that gives me the area of this sector, which comes out to be 113.112, I think, if I'm not wrong. Let me check that value again. So it's 112, and if I round it to 1 decimal place, okay, it's 113.1 meter squared again. Okay, unit of area should always be same as unit of radius, okay, because that's the only length I'm using. Okay, now if I move move forward on these questions. Okay, let me see what we've got. Okay, I've got a question here where it says to find the shaded segment. Okay, area of the shaded segment. Now, what would you do in this case? I mean, clearly that segment is actually a sector here. Okay, that's a full sector, and inside the whitish bit is a triangle. Okay, so I can work out area of segment. So I can work out area of segment. Area of segment is area of sector take away, I've got right angle triangle here, white bit, area of triangle. So what I would do, I would first work out area of sector. Okay, my radius is 5. Okay, so area of sector is worked out using this formula, theta over 360 degrees times it by pi radius squared. My radius is 5, theta in this case, now that's a right angle, which means it carries quarter of the area full circle. So what is right angle? It's 90 degrees. So 90 degrees over 360 times pi times 5 squared, right? So that should give me the area of this sector. That makes a quarter anyway. Okay, and the value of pi is 3.142. okay, and 25 is the square of 5. So that gives me, if I use a calculator, let me use calculator for that. Okay, my calculator says that 3.142 multiplied by 25 and share my answer by 4 gives me 19.6375. So if I write this down, 19.6375 centimeter squared, okay, because the radius was in centimeters. Now what I need to do is I need to find area of triangle. Okay, area of triangle, as we all know, is half base times perpendicular height. So in this case my base and height is same, so it's half times 5 times 5. Okay, because an isosceles right angle triangle, so it's 25 divided by 2 is 12.5 centimeters squared. So shaded area is, we know we did that there, that area of segment is area of sector take away area of triangle, so it should be 19.6375 take away 12.5. okay, and if I try my calculator has got that value already in, so take away 12.5, which gives me 7.135. okay, so it's 7.135, so up to one decimal place is 7.1 centimeters squared. Okay, so this is how you're going to find the area of shaded part. Okay, now if I look back, I mean what we have learned in this case is how to find the area of a sector. Okay, and then in this case how to find the area of a segment. Okay, so I hope this would have been useful. Thank you for watching.